So for this question, we're dealing with the electron flow through a wire that's affected by a horseshoe magnet that's producing a magnetic field. And so if we're determining the way the wire is deflected by the horseshoe magnet, we're gonna have to use our left hand because it's an electron flow, and so we know the electrons are flowing this way, and the horseshoe magnet's flowing from north to south. So we'll set it up like this, our hand like that, and it shows that our palm or our hand is facing down. So we know the FM, as drawn by this arrow, is going to be facing downwards. And so when we're asked to determine the values and units needed to create the chart given above, first we convert our scale readings into kilograms by dividing by 1,000. As you can see, we did right here. And then we're going to multiply by 9.81 because that's the acceleration, and F is equal to mass times acceleration. And the reason we're allowed to do that is because the scale was zeroed before with the gravity, with all the stuff on the scale. So any additional force will be the result of magnetic force because it's in the exact same direction as gravity. And so we create these points where the current is a manipulated variable, which creates different magnetic forces. And we create a graph, and it shows that they're directly related, and there's an increasing slope. And I created a line of best fit that's approximate on the line. And I took 2 points that were on the line, and I created a slope, which is also equivalent to rise over run or y over x, but most importantly, magnetic force over current. And what this does for us is when we rearrange the formula, because we're looking for the horseshoe magnet, we're looking for the strength of the magnetic field produced by the horseshoe magnet, so B. So we know FM is equal to I, which is current, times L times B, L being the length of the wire, and L being 0.025 meters. So we reorganize the equation for B, which is B equals FM over I times 1 over the length of the wire. And we can actually show that the slope is the exact same as FM over I using our graph. And so we can just replace that FM over I with slope and then multiply it by 1 over the length of the wire, which gives us a B value of 0.13 or 0.1321733913. And so two important concepts that we use in creating this were the third hand rule, which I explained at the beginning, using our fingers and our thumb to show the direction of the deflection of the wire. And then another important thing is the idea that magnetic force is equivalent to Fg because it's in the same direction.